All right, today we're going to take a look at the thin layer chromatography or TLC lab from Smart Sparrow. So this is your ultraviolet light box, so that way when you take your slides out, you put them in there, and when you turn it on, then it'll light up, and then there will be a slide up here, and the grid, which is a 1 centimeter squares on there. First thing you have to do is get out a TLC plate, and we have to spot it. So we put it on our lab bench, and then what you need to do is get a capillary tube. You dip it down into your aspirin solution, and on the first dot, you spot it, and you recycle that one. Get out a new capillary tube, dip it into the acetaminophen, which is Tylenol, and we're going to spot that plate. Now, I also put on Google Classroom some actual pictures of a TLC lab that I did last year, so you can see what it actually looks like. This one is actually a fairly good. See, if you put it over the wrong spot, oh, you've already spotted there. So wait till it turns blue, spot it, and then you're unknown. And so now this plate is all spotted and ready to go. So the first thing that you want to do then, we'll click through over here so it's on the right spot. I kind of jumped ahead a little bit. It tells you to go ahead and spot the plates, gives you some background on thin layer chromatography. I'm going to go ahead and put this in there in there so that way it starts developing. You need to make sure that you always measure from your reference line, a pencil line down here, because if you used ink, the ink would go up with any solvent along with your dots. You wanted to let it get up pretty far up to the top. I would let it get to right about where that line in the beaker is there. And these are pretty much the same solvents that we would be using if we were in an actual lab. So over here you can see there's a picture of developing the TLC plate, which is a silica type material on a piece of plastic or glass. There's a close-up of it, kind of the same pictures that I uploaded on Google Classroom. And while that's developing, I'll click through. Now keep in mind that Smart Sparrow is a virtual lab. It's not a video. And every time you do the experiment, the numbers will change a little bit. So the numbers that I get are going to be a little bit different than the numbers that you may get. And if you restart the lab, then what'll happen is the same thing. The numbers are going to change a little bit. All right. So this one looks like it's about done. See how it got pretty much up there. So you put it on your UV lamp, turn it on, and then turn the grid on. This darker line here is your solvent front. And so you always measure to the farthest point of it front, solvent front. So what we have to do is we got to figure out distance traveled by the aspirin. So we have 1, 2, 3, 4, 5, and it's not quite up to the 6 centimeter mark. So I would call that probably 5.8 centimeters. You always want to go to the limit of the scale, 1 digit beyond, so you have to interpolate between those lines. And it should tell me that I did it right. Yay! And then you're going to measure the distance that the solvent front moved. So the solvent front moved 1, 2, 3, 4, 5, 6, and a little bit more. So I would call that probably about 6.2. And then in order to calculate the RF, you have to get out your calculator and you take the distance that the spot moved divided by the distance of the solvent front moved. Now the largest you could get is 1. This one is kind of strange where it's actually a little bit past the solvent front. It can't really go past the solvent front other than the dye. Some of the dye absorbed the solvent and it traveled a little bit further up there. usually it's the max, the solvent front and the dot are going to be exactly the same. So if I take 5.8 divided by 6.2, I get 0.935. So I'm going to call that 0.94. And no error message, so that way it tells me then that I did it correctly. As on the previous page, report your calculated values for the RF for aspirin, caffeine, and the unknown from the TLC run using ethanol. Well, for the acetaminophen, I would say that is 1. For the caffeine, again, you want to measure the solvent front over the dot each time. So we have 1, 2, 3, 4. That's about 4.5 for the distance that the spot moved. And then there's 5. Yeah, we'll call that 6. So we'll take 4.5 divided by 6, 0.75 for the caffeine. And then of the unknown, 1, 2, 3, 4, 5, about 5.9 divided by maybe 6.2, 0.95. Now, once you are done with the slide, you can go ahead and answer the questions here. You can kind of eyeball and you can tell here's your unknown and here is the aspirin. It looks like it's going to be the aspirin. Now, when you're done with that one, you turn this off, take your slide, and I would simply put it up here, or maybe down here, so that way you can remember that that one's in the ethanol, so that way you don't use the slide for the ethyl acetate in case you got to go back and remeasure it. And you can move these around a little bit as well. I guess just the beakers will move. And then you get a new slide, and you do the exact same thing. You're going to spot it with the same 4, put it in the ethyl acetate, do another slide, put it into the CH, and then continue measuring the RFs that way. So I'll kind of do a fast forward here and see how it turns out. Now you can see on this one, I kind of noticed when I did that, it didn't spot on there and the capillary tube went back over. So this plate didn't get spotted. So what I would do is I would just get a new plate and redo this one. All right, now we can see that the solvent has moved quite a bit, but our spots have hardly moved at all. So this is not very soluble in our organic solvent, which is a nonpolar solvent. And so if I turn the grid on, you can see 1, 2, 3, 4, 5, 6, 7, about 7.5, but each of them only moved up a little bit. So this is probably about 0.8. So 0.8 divided by 7.5 gives me 0.11. All right, so again, once you've gone through, I would save your TLC plates there just so that way in case you got to remeasure them. So just put them next to the solvents so that way you remember which one is which. And again, in mine, it looks like that it's aspirin is the one that's closest to it. Again, depending on how long you leave these in the chambers, you're going to get different values for how far they move, but your RFs should all be about the same. So that's why I saved the slide. And I could see that the second one here, the acetaminophen, actually went the most. So I would say that that would be the answer. Which compound has the weakest relative attraction to ethanol? Well, that would be caffeine then, because it did not travel nearly as far up the slide as the acetaminophen or the aspirin did. So I'll just click on caffeine and go to next. Now with the ethyl acetate, you do the same thing. So I'll turn off my lamp, put this one back over here to save it, and then you would take your slide, put it back underneath there again, and do the same thing. The one that's going to have the strongest affinity for it, or the strongest attraction, which is another name for that, is the one that travels the farthest. The one that travels the least amount has the least attraction in the solvents. And then on to the third one as well. All right, based upon the structures of acetylsalicylic acid, which is aspirin, acetaminophen, and caffeine, including their functional groups and overall polarity. Again, some of this is kind of beyond the scope of our class, but it's still very useful. You can look it up. You can Google it if you wanted to as well. But we'll see if we can't figure out these answers. So these probably will be the same for everybody, but I am not sure if it does or not with the program. Smart Sparrow doesn't give me the answers for them either. And that completes the lab.